Hi, this video is going to talk about chapter 5.4, which is looking at equilateral triangles as well as isosceles triangles. So two of the big theorems from this chapter have to do with what's called the base angles. Okay, here we go. So the base angles theorem states that if you have an isosceles triangle, meaning that you have two sides that are congruent, then the two base angles will be congruent as well. Okay. So in other words, when you have an isosceles triangle, not only are two sides congruent, but you're going to have a pair of angles that are congruent as well. Okay. And then the converse of that theorem, which is kind of the reverse of it, is saying that if you have a triangle where two angles are congruent, right, those would be the base angles, then you can claim that the two sides are congruent as well. Okay. So in other words, triangles like these, which are called isosceles triangles, have a pair of congruent sides and a pair of congruent angles. All right. So with that, let's go ahead and take a look at a couple of questions here. All right. So for these questions, we need to complete the statement and then name the theorem that we used. Okay. So the two theorems that we could use are the base angles theorem or the converse of the base angles theorem. So the base angles theorem is used when you already have a pair of congruent sides and you're trying to claim that you have a pair of congruent angles. And the converse is the opposite. It's when you already have a pair of congruent angles and you're trying to claim a pair of congruent sides. So we'll just kind of leave that note there. All right, so question number one, it says if the segment NJ is congruent to NM, so those two right there, then which two angles are congruent? Okay, so in this case, the triangle that I'm looking at is this one right here. Okay, I've got I've got the pair of congruent sides, and I've got to find the pair of congruent angles, which is going to be the base angles, right? Or the angles that are opposite of the congruent sides. So this would be angles M and J. All right, question two, now it says if the segments, oh, sorry, forgot to write the theorem here. So this would be base angles theorem. Base angles theorem, right? Because I'm going from the sides to the angles. Okay. All right, question two, it says if the segment LM is congruent to LN, okay, so now the triangle that we're looking at is this one. Okay, what are the two angles that are congruent? Well, I just need to look at the angles that are across from the sides with the tick marks, right? So that'd be angles M and N, right? Just kind of turn your head so that it's oriented the same way that the triangle is. Okay. So angles M and N, and that was also the base angles theorem, right? We started with the congruent sides and we're making claims about congruent angles. Okay. All right, question number three says if angle NKM, right there, is congruent to angle NMK, right there, okay, then which sides could we claim as congruent? Okay, so based on those two angles, I know that this is the triangle that we'd be looking at. Okay, if I go across from these angles, that should tell me the two sides that are congruent. So across from angle M is the side KN, and across from angle K is the side MN. All right, so I would say KN and MN are the congruent sides. And this is using the converse of the base angles theorem. Okay. Last question, number 4. If angle LJN, so that's that one there, is congruent to angle LNJ, which is that angle right there, okay, then what are the two sides that are congruent? Okay. So based on the two angles, I know that this is the isosceles triangle they're referring to. Okay, and this is kind of the orientation we would expect it. We would expect the base angles to be at the bottom, and then the two congruent sides to be, forming the peak. Okay, so LN would be one of the congruent sides, and LJ would be the other. Okay, LN and LJ. And this would be another example of using the converse of the base angles theorem, because we started with congruent angles and we're making claims about the congruent sides. All right, so I'm going to stop this video, and then there'll be some more videos in this series about equilateral triangles and isosceles triangles. All right, thank you for watching.